interested not only in finding an efficient way to decompose water for fuel, but also he was interested in showing that it can be applied to everything, from jet engines to home heating to power generation to just running cars down the road.
Yes, he was, because as time went on, Stan and I talked about things, and we were learning and talking about things, and then we could see, we started to get a sense and a feel that there was more to this, that there's more to this process. We started to see a tremendous amount of energy available. You know, if you go into if you look at the organic chemistry, you start to look at the breaking of the bonds, and you start looking at the ionic bonding and the valence bonding, and then you start looking at how the combustion process works, and then you start looking at the atoms, and that's a point I want to make, that I hear these things like over unity, and I hear things like perpetual motion, and people use them quite indiscriminately and really in the wrong context. And let me give you a case in point. Perpetual motion. I hear this word perpetual motion, but originally what happened was, when they were developing the microscope and they were increasing the magnification, you know, and as all new inventions, the magnification gets better and better and better, and what happened was they were using pollen. And we can't see pollen, it's so small, but they were putting pollen into a drop of water, and when they were doing the magnification, they saw that the pollen was always moving. And so every time they went back, they said, well, it's perpetual motion. It's moving. So they went to Einstein. And so and asked Einstein, says, what's causing the motion? Is it the pollen causing the motion, or is it the water? And so Einstein said, he looked at it and studied it and came back and says, well, the water is what's pushing around the pollen. Well, there was a spin-off from that because Einstein was able to determine the size of the water molecule. So that's the key what perpetual motion is. Now, when you come to over-unity devices, that's another terminology that people definitely are not using correctly. If you look at, if you took a piece of paper and you drew the x-axis and the y-axis, and you go down into the lower left-hand corner, and you start drawing an exponential curve, if you draw at the very lower corner area, you could draw and say, okay, that's where we look at what I call linear functions of our universe. When you look at what's in motion stays in motion and so forth with Newton's law. But then again, if you continue on the way up in the exponential curve, you can go up to, let's say, 3-4 inches on the page, and you get to the top of the exponential curve. And that's where Einstein realized and was able to derive from the equations, he is able to derive and determine that E is equal to mc squared. Now, the point in case is that it was Einstein's work with photon energy that he discovered and realized that mass can change into energy, and energy can change back into mass, which is huge amounts of energy. Now, that the energy is locked in every atom, and it is locked in because in the universe you have hydrogen and you have helium in the universe, and then when the stars explode, when a supernova explodes, it actually is so much energy, and the temperature is up in the trillions of degrees. The elements are formed. All of our elements are formed at that time. And when that happens, it stores a huge amount of energy. And so Einstein realized that these atoms have a huge amount of energy. Well, when you look at combustion in an automobile engine, the combustion process only uses 1/millionth of its mass energy. Only 1/millionth of its mass energy. So if you did something, you add these products, the hydrogen and oxygen, to this process of combustion, and you get a little more energy out, all you're doing is basically converting a little more of that mass energy. That's where it's coming from. So when people say you got over unity, they'll realize how much energy those atoms have. So you have valent bond energy, you have ionic bond energy, and you also have a mass change energy.